Doing great. Yeah. All right, before we get too late in the day, it is 9:07, we're going to go ahead and bring the next meeting in order. I know, Wayne, we probably need to do the housekeeping remarks again, correct?
Sure. Let me just start with one housekeeping remark first, and that's for all the guests that have checked in under the South Coast AQMD board retreat. When you check out, you don't need to pay for parking. And when you get your car picked up, make sure to let people know your room number and your last name. And again, you should not be charged for parking. And then as regards to housekeeping comments, if you could just give me 1 or 2 minutes, Mr. Chair. I forgot about that.
You don't have them memorized yet? All right. Please stay off your devices. If you're in the room, don't log into Zoom. And what's the other ones?
There's 3 modes of participation.
3 modes of
One is by
participation.
Zoom, the other is by teleconference, and the other is here in person. And for those participants participating by Zoom, if you want to speak, you can press the raise your hand button. If you're on the teleconference, you can press *9. And if you're here in person, we ask that you fill out the blue card, provide that to the clerk of the board in the back, and your name will be called when appropriate. Also, if you're participating in this conference, you understand that this conference is being recorded and that you agree to the recording and that you also agree to the subsequent use of that recording in the public domain by the South Coast AQMD. As to decorum, we ask that you treat everyone with courtesy, civility, and respect. Failure to do so may result in your mic being muted or you being dropped from the line. And we thank you all for your participation today.
Very good.
Thank you, Mr. Chair.
Thank you, Wayne. I do have a comment card from Yasi for ozone measures. Yasi, is that for the first item or after the first? Oh, got it. Okay. Very good. With that, we'll go ahead and get into our first item, the NOx and ozone attainment strategy background. Dr. Sarah Reese, tell us how we're going to get there.
You have such great confidence in me.
Oh, that's a great way to start.
It's an auspicious start to the morning. So good morning, Chair Benoit, members of the board. My name is Sarah Reese. I'm the Deputy Executive Officer for Planning at South Coast. And this morning, I'm going to start talking about ozone chemistry in the South Coast Basin. Let's see if the Yogan clicker works.
Aaron put a battery in it.
It's all Aaron's fault. Yeah. So actually, if you can back up. Great, we're on the overview. So basically this presentation is queuing up a more in-depth presentation that Dr. Ronald Cohen is going to give after I speak. We're very fortunate to have Dr. Cohen with us here today. He's a professor from University of California, Berkeley, with the Department of Chemistry, a distinguished professor. He has a long body of work studying the South Coast Air Basin. So he'll be able to share and shed a bit more light on the specifics and some of the factors that are going into forming ozone and why we find ourselves so entrenched with high levels of ozone in our area. But I want to go give a kind of a quick overview of, at a high level view of how ozone forms in the South Coast, and then talk about some of the impacts of weather conditions, climate conditions, and then some other influences. So next slide, please. So ozone chemistry 101 at a very, very high level. You've heard me talk before about how it's the reaction of volatile organic compounds and nitrogen oxides. They react in the presence of sunlight. It's basically like they cook in the presence of sunlight and then form ozone. In the LA area, we kind of have the perfect conditions for ozone formation because we've got a lot of people, we've got a lot of engines, they produce tons of emissions. We have great weather, so a lot of sunlight, and we also have a lot of weather conditions that cause stagnant air conditions. And then we're situated in a basin. And so we're surrounded by the San Gabriel Mountains. We have coastal breezes that push the emissions inland. They push up against those mountains, they get trapped, and they have more time to react and form ozone. But the reactions are actually a lot more complicated than what I'm describing. There's a lot of individual building blocks that are produced, these intermediate species that come and go. And so that's why if we have a molecule of VOCs and a molecule of NOx, it doesn't necessarily add up to like one molecule of ozone. And so similarly, when you start making those reductions, you don't necessarily reduce them in a linear way. And so we're going to talk a little bit about what some of those influences on those reactions are. There's dozens to hundreds of intermediate reactions that can happen depending on ozone chemistry. In the past, we've had very, very high levels of ozone in our region. We still have high levels, but we're coming down, and you've seen that on the charts I've walked you through yesterday. But as we go, when you're at very, very high levels of ozone, VOC control is more important and really the key to being able to reduce. As you move down, as you get down to the lower levels of ozone that we need to get to in order to attain federal standards, that's when you need to turn more to a NOx approach, where NOx is more important to be able to reduce. Next slide, please. A little bit more detail on ozone chemistry. So the central reaction ongoing here is really NO2 to ozone. The NO2 molecule is a nitrogen molecule with a nitrogen atom with two ozone atoms. Sunlight comes in, the ultraviolet radiation knocks off one of those ozone or oxygen atoms, and then that oxygen atom flies around, finds another oxygen molecule, forms ozone, O3. If we didn't have any other chemical building blocks in the atmosphere, if that's all there was to it, it would be a cycle. And so as the ozone is generated, ozone's not all that stable in the atmosphere, so it would dissociate and then go back to NOx and oxygen. But we have other compounds that are in the atmosphere. So we have these, what we call these intermediates. And when these building blocks are in the atmosphere, they kind of interrupt the cycle. They can react and form more of different species. And so what that generates is a net increase in ozone, or can when you have the right conditions. VOCs are kind of the source of those building blocks. So I like to think of VOCs as kind of the fuel for the reaction, and then the NOx, the nitrogen oxides, is really, they act more as a catalyst. You need both of them in concert to be able to get this cycle to work, but under those right conditions, you wind up with a net increase of ozone, and so you don't, it breaks that cycle. And it's in fact a runaway reaction. So it's when we continue to get the sunlight, the ultraviolet radiation, it just continues to generate more and more ozone. Again, the nature of these specific reactions is very, very complicated. They will change depending on the ratio of NOx and VOC in the atmosphere. So it's under all kinds of circumstances. Sometimes if you have a reduction in NOx, you might get an increase in ozone. Sometimes if you have a reduction in VOC, it's an increase in ozone. It just really depends what's going on in the atmosphere at a given time. And then transport and aging of the emissions also will impact the formation because they need the time in the atmosphere to cook and react with the sunlight. Next slide, please. You've seen this slide before. Sorry for the extra text box in there, but this is just showing how we've been able to reduce emissions over time. And again, this is a good story. We've made dramatic reductions in emissions that have resulted in our reduction in ozone concentrations, but we're seeing a bit of a leveling off on VOCs, still have a ways to go on NOx. I will note here that biogenic VOCs are not included, so VOCs from vegetation, from trees and plants, which is a fairly significant chunk of our VOC emission inventory. Those are not in here. Next slide, please. So another factor when we think about ozone is the area where the emissions are coming from is not necessarily the region where we see the highest levels. So we get the emissions are coming from the highly urbanized areas of Greater Los Angeles. That's where we have our ports. That's where we have all of our goods movements. So these big heavy engines generating tons of NOx. And then where we tend to see the higher levels of ozone more towards the Inland Empire, up in the mountain areas. That's because those emissions need the time to process, to transport, and to cook. We also see, not as high levels in the Coachella Valley as we see in the South Coast Air Basin, but Coachella Valley also fails to attain ozone standards, largely because emissions are transported from our region to Coachella, both the ozone itself as well as additional NOx and VOC emissions transported over there, and then they react under the sunlight there. Next slide, please. And so there's a little bit of the transportation pattern that I showed you, where we do see that movement and continued generation of ozone in areas that are further away from where those emissions are generated. Next slide. So this one is a bit of an animation. This is showing ozone formation during the day, and you can see kind of the impacts of transportation and sunlight. And so this is the starting is at 7 o'clock in the morning, and you can see as we go on, by the time we hit about 11, where the sun is really firing up, we see the higher levels of ozone forming, and then getting into some pretty unhealthy levels. So this was a snapshot of a day, I believe, August 4th of 2021, which was a pretty high ozone day, but it's just illustrative again of how ozone forms when we get the sun with the transportation factors included.
So that data that we're looking at there, is that something that you can look at live, or is this it's not radar that you're seeing that off of, right? What is that coming from?
No, this is model data. There are, so on APA's website, and I believe also on ours, we do have models on the air quality index,
Right.
but this particular one is model data.
Okay. Very detailed. Thank you.
So next slide, please. This is, the chart that I've talked about yesterday, my good news, bad news chart that shows really good reductions in ozone for both South Coast Air Basin and Coachella over the last several decades, but a flattening off and an uptick. And if you can click again, Paul. So this question today is what's causing that disturbing uptick that we've seen over the last few years, where despite our best efforts, despite reducing emissions, we've gone up in ozone concentration.
Dr. Reese, I know this is the preliminary data for 2021. When do we think we have the full data?
We should actually be close. I'll have to check in with my folks, but it takes several months to finish quality assurance and quality checks on air monitoring data.
But it looks like it's flat or a little bit higher, or?
So what these are 3-year design values. So if I looked at like the individual annual one, we would have seen a peak in 2020 and then slightly lower in 2021. But because these are 3-year averages, that's where you see the little bit flattening. 2020 was a year that was pretty bad for us in ozone. Okay. And then I mentioned yesterday the level of background ozone. We do have a certain level that's always there. It's about 45 ppb, but it shows that there's still some space for us to get emission reductions from man-made emissions. Next slide, please. So our, the golden question, why is ozone going up? You guys are doing everything, keep telling us we have to follow a NOx strategy. You tell us the modeling and all of the emissions that your team of PhD scientists have put together says that this is the right track, but we're not seeing the results. And one of the reasons is the regime we are in, this kind of crazy regime with all these different chemical reactions going on. We're in a place where if you hold VOC emissions constant and reduce NOx emissions, you're going to expect to see some increases in ozone before you get over that ridge and start to see the decreases. And if you look back at the earlier chart I had on VOC and NOx emissions, our VOC emissions have leveled off over time, whereas NOx is going down. So we're right in that spot where you're going to start to see some unintended consequences or unexpected consequences, because the strategy that's ultimately going to get you to attainment is causing short-term increases in ozone. It's one of the reasons why in our draft air quality management plan, we do look at strategic VOC reductions, because we know in the short term, VOC reductions are going to help us with ozone. But ultimately, when we go through our models, we see absolutely no path to getting to attainment if we just focus on VOCs. And even VOCs in concert with NOx, it's really got to be a NOx strategy. We really got to get massive reductions of NOx to be able to get to where we need. Dr. Cohen's going to talk about more of these factors in more detail, and he's certainly far more expert in this area than I am. Another question we get all the time is, well, what about climate? Because we know that sunlight is a key factor in ozone formation, and we know we're going to get hotter weather and more stagnant periods of weather with that as well. Next slide, please. So this chart shows projected, these are actually temperature increases over California from that NOAA modeled from basically just over the last 100 years. You can see that it's over the last 100 years, things have gotten pretty toasty in our region. So temperatures have gone up, and we also with that, we've had an increase in stagnant weather during the summer conditions, which really increases formation of ozone. And so we do know that in the future with climate change, we can expect that we're going to see more of this. And in fact, that's somewhat of a climate penalty that we might expect to suffer and make it just harder and harder to get those reduced ozone concentrations to safer levels. Next slide, please. And then EPA has done some modeling of their own. So in their national climate assessment, they looked specific across the nation for different scenarios of a high greenhouse gas emission scenario and then a low greenhouse gas emission scenario, both for years 2050 and 2090. And you can see that they've modeled that there was some increases in ozone in the Southern California area as a result of these climate scenarios. We see much higher increases the higher the greenhouse gas emission scenario is. I will note that these scenarios don't include the reductions that we are looking at in our ozone control strategy. So we're hoping to get ahead of that with the measures that we put in place that get us into a better regime. But it just shows that if we do nothing, climate is going to have an influence and continue to increase ozone levels above what we currently experience. Next slide, please. And then, we've done some modeling studies ourselves that look like that there'd be from climate impact an additional 1 to 2 parts per billion of ozone in our top areas, going up to 6% in some locations. And so there's a lot of uncertainty associated with this because there's many factors that go into the formation, but we believe that we'll be seeing a signal from climate as we move forward. Next slide.
Does the AQMP include any of this on climate?
We don't specifically go through those details on climate. We model, what the base emissions versus projected future ones are. We have our weather scenario is set in. We have a particular scenario that we look at. We don't particularly evaluate climate as a part of that. It is something though we're going to have to keep track of as we move in the future.
I mean, it would seem if some models are showing a potential increase up to 6% by 2037. That it is something that we should be looking at in the document, no?
Well, again, I believe that particular scenario might not have included other strategies that we have in place to reduce emissions, but you're right, it's an important point and we need to keep that in mind. So then looking at the effects of weather conditions on ozone formation, again, these hot days, these sunny days, stagnant conditions, very, very effective at forming ozone in our region. What we see when we have year-to-year swings in ozone levels, so like year 2020, for example, which is very, very high, meteorology really is a dominant factor. We just have these perfect weather conditions to get this perfect storm for ozone formation. And we can see the weather conditions actually can influence ozone very, very strongly, up to an 8 part per billion change due just to weather conditions alone. And next slide, please. So just the overall summary, again, we see that ozone is have the perfect conditions in our region for ozone formation that's then transported out to our Inland Empire and Coachella Valley and impacts ozone levels there. Those reactions are very complicated, but again, our modeling confirms over and over that right now we have to stay the course on a strategy looking at NOx reductions to be able to attain. It is influenced by higher temperatures. We know that our future in a warming scenario, we would expect to see higher ozone levels as a result of climate change. But right now, weather is really the stronger influencer in terms of year-to-year variation. So with that, I'm going to cue it up for Dr. Cohen, who will be able to speak more knowledgeably. But first, Mayor McCallum.
Thank you very much. The previous chart was for Crestline site. How does that compare with the Redland site, which is now really the design site?
Let me see, scroll back up. Yeah, so Crestline used to be our design site, which is why we have this one here. And then the sites, we've seen them sort of trade off over the years a little bit, but you're right, Redlands right now is our design site. I'd have to go back and specifically look at what that would look like.
Thank you.
Okay. Clicker, which hopefully Dr. Cohen has a magic touch on the clicker because it didn't work for me.
All right, thank you so much for a chance to speak with you today. I really appreciate it, and thank you to Sarah for setting this up so well. Most of what I'll do is try and reinforce and just say the same thing Sarah just told you in different words. I see your tradition is to interrupt people when you have questions in the middle. Please do that with me too. Let me tell you a bit about my background and some of the kinds of things that we're working on. I'm a professor in a chemistry and earth sciences department and I sit at that interface. So sometimes thinking about the atmosphere is, as you just heard, a meteorology problem, and chemists usually don't think about meteorology. They think about things on timescales of one collision between molecules, or sometimes femtoseconds, and in the atmosphere, those timescales don't matter very much. But on the other hand, when we think about the chemical reactions, the chemical reactions are what chemists do. And so sitting at that interface and going back and forth between those two communities has strengthened my work over time. And we have 3 different kinds of projects going on in my research group right now. One, I just came from a low-cost sensing meeting in Pasadena. We're very, very interested in what you could do with, if you put out enough sensors to map a community. In the case of the network, I'll show you on the next slide a little about our network, just to give a sense of some other things. We do a lot of work on observing urban chemistry from space, looking at long-term trends and the advantages you have of having complete coverage with a satellite, which sees every spot on the planet. It's not just the points where we're able to make measurements at the ground. And then we've done a lot of work thinking about the role of plants, both in their effects to remove chemicals from the atmosphere and emit chemicals to the atmosphere. And plants and forests serve both purposes. So let me just give this one example. We all know that during the COVID-19 shutdown, there was a dramatic reduction in traffic and commuting and vehicle-related CO2 emissions. In this project, we took measurements in the Bay Area at all of those locations with the green dots you see there. So we're measuring CO2 and criteria air pollutants at every single one of those locations. And then we did a formal mathematical inverse, so a fancy way of saying we fit the emissions to match the observations using the weather from those days. And we're able to quantify how much emissions of CO2 and vicariously then all of the other emissions decreased, and to sort that out by sector. So you can see the vehicle-related sector went down dramatically. That's the orange line on this plot. And the industrial and the didn't change anywhere near as much, and the growth of plants took a little CO2 out of the atmosphere as spring went along in that time period. And we're trying to do the same thing here in Los Angeles. So we have a little piece of that network and same strategy, starting at USC and going west from USC in collaboration with Will Barrelson. And we're hopeful to grow that network and support thinking about greenhouse gas and air quality emissions reductions in the Los Angeles basin. Okay, but today we're going to talk about the intersection of temperature and emissions as they affect the frequency of high ozone events. And as you just heard from Sarah, meteorology and the future of climate is an important factor in thinking about this. So we like to think of it as, if you know the temperature on a given day, what are the odds you'll have a high ozone event? And to frame it that way, and then separately, we can ask our climate friends to tell us what are the odds of having a certain number of hot days in any given year, and how is that changing over time? And that logic sort of allows us to separate the way we think about the weather and the climate. So as I go through this, I'll talk to you about what the odds were of having a high ozone event on a hot day 20 years ago and what they are today. And then separately, we can say, well, last year there were 10 hot days and this year there were 3, or vice versa. So how do we think about those two factors separately? This is work that was partially supported by NOAA and the Climate and Air Quality Division there, and comes published in these 2 papers, looking at the intersection of temperature and nitrogen oxides in Los Angeles for ozone, and then another one looking at the parallel aerosol issues. So as Sarah told you, there are 3 ingredients for forming ozone. It's volatile organic chemicals, nitrogen oxides, and sunlight. And regulation here leading the way for the rest of the planet. Everyone follows LA and how they think about how to clean their air. Regulation has been incredibly, incredibly effective. But one thing I want to remind you is that nitrogen oxides are mostly a direct byproduct of combustion, and volatile organic chemicals find their way into the atmosphere from many different ways. And some of those ways are evaporation. So evaporation, just the same way more water evaporates when you boil water and it's hotter, organic chemicals evaporate into the atmosphere more when it's hot. So that's something to keep in mind. There's a VOC control that's incredibly effective and perfect when it's 50 degrees outside, might not be effective when it's 80 degrees outside because different processes are contributing to the evaporation at 80 degrees than at 50.
Excuse me, Dr. Cohen. If I could just make an announcement. To everybody here, we just understood that one of our employees tested positive for COVID-19, and we have masks, if anyone is interested in wearing those masks today. The employee is with us yesterday, and just want to make sure that there's a disclosure and let everybody know that we have masks in the back. Scott, if you could raise your hand so people can see. If anybody wants to take that precaution to wear a mask, we have those available for you. So thank you, everybody. Thank you. Sorry.
Thank you. That's more important than anything I have to say. And I'll just wait a second for people to grab a mask. So let me, scientists like to think about experiments where you can take one variable and control it and change it. And the atmosphere rarely offers us that opportunity. But one of the things where the atmosphere comes closest to that is our weekends. On weekends, most of the heavy-duty diesel truck traffic is off the road, and heavy-duty diesel trucks emit mostly CO2 and nitrogen oxides, and by comparison, small amounts of everything else. And so as a consequence, weekends are kind of like changing only one thing, changing only the nitrogen oxide emissions. And you see here the incredibly effective controls over the last 25 years on nitrogen oxides, almost linear at about 7% per year decrease. And that decrease happened on weekdays and weekends. It's a consequence primarily of catalytic converters on passenger vehicles, a little bit of controls on heavy duty trucks. And you see the really large fractional change. Now it's about 50% decrease on the weekends. So that's an experiment, and it lets us look at one of these three ingredients. The sunlight doesn't know whether it's a weekday or a weekend. The things that are evaporating because it's hot don't know if it's a weekday or a weekend. We tend to drive about the same amount on weekdays and weekends. We just drive to different places, those of us with passenger vehicles. So really it's just, the weekend effect is almost always just the trucks, and it's just nitrogen oxides. So it's a really good test of our understanding, and it's often a good predictor of what will happen from nitrogen oxide controls when we reduce them by 50%, because we do that experiment.
Can I ask a question, Chair? So that's because there are less heavy-duty trucks on the roads during weekends?
Correct. Exactly. And so if you just compare the shape of this curve showing what's happened to VOC over the last 25 years to the previous one on the nitrogen oxides, you see the fundamental difference in how things are behaving in the atmosphere. So the volatile organic chemicals in the atmosphere are decreasing, but the decrease is dramatically slowing. And they're a little bit lower on the weekend, but nowhere near as significant as the nitrogen oxides. So this is the fundamental difference in what's happening in the atmosphere between those two ingredients for ozone. And, what I'd say is, one way, and right, these are the concentrations. Sarah showed you the emissions. The concentrations are affected by, largely affected by things that can't be regulated. Trees, as one example, emissions from the forests and trees both within the city and the surroundings. Other things that are perhaps not yet regulated.
Real quick on the trees, are there particular trees that are worse than others for VOCs?
So I think the answer is yes, but I am insufficiently expert to tell you which ones. Wow. But yes, I mean, I know that Los Angeles had a plan to plant 1 million trees. And I would say one of the things that we as a community should do is identify which trees would be the least VOC emitting, right, and encourage planting of those. And I'll come back to that point. I think it's a really important point. And so here's just showing you 20 years ago and today, or 20 years ago and 4 years ago, what the temperature dependence of various organic chemicals in the atmosphere. And you see all of those lines are a little bit higher at high temperature than low temperature. So that's a key idea. You see that isoprene is relatively less different today than 20 years ago than anything else. And that's because isoprene is the main chemical emitted by trees. It's also one of the fastest reacting molecules in the atmosphere. So isoprene, which is one of the chemicals that would be that, 100 years ago was the ingredient in rubber that would have been a dominant source, and rubber factories were contributed to recognition of the ozone problem during the World War II and just after in Los Angeles. But today there's hardly a change in the last 20 years in the isoprene in the atmosphere, and that's because it's probably mostly from natural sources, at least land use related sources and not mobile sources. If we sum this up, we made this figure, combining observations and models in a consistent way. We measure some of these chemicals in the atmosphere on a regular basis. You guys have your, in various places in the basin, measure a very wide suite of organic chemicals. And then we use models to fill in the gaps for things that are important that are not measured. And I just want to point out the difference between what's important at low temperature and high temperature. So green here are things that are emitted by plants and consequence of secondary chemicals that arise from the reaction of things that are originally emitted by plants. And you can see that at lower temperatures, they represent about 1/4 of the VOC, and at high temperatures, about 1/2. And that's a key feature of how to think about this going into the future, that on hot days, the relative importance of different chemicals is different, and the relative importance of chemicals from plants is much, much higher than on a cool day. The red in these figures are things that are largely controlled by the sorts of regulations that you put in place. The green are things that have big components from the background because they're very slowly reacting. Methane as one example, carbon monoxide as the other. Those can be partly controlled and partly not locally. And let me just point to the number. It's roughly a factor of 2. There's about a factor of 2 more organics in the atmosphere on a hot day than a moderate day for Los Angeles. So this summarizes what I just said, that today other sources of organic chemicals are about equal to the ones from cars and industry. And at high temperatures, those other sources are more important than vehicles. The other sources are trees. And then in the research community, there's a lot of interest in the kinds of chemicals that are used for personal care. So we use solvents in our shampoos and deodorants and all kinds of other things that didn't used to be relatively important because emissions from cars were so high. And as we've reduced those emissions, the kinds of emissions from those personal care products and household cleaners and other things where we have alcohols and other things that are designed to evaporate are becoming a larger and larger fraction of the chemicals emitted to the atmosphere. We suspect those aren't temperature dependent, but there's an ongoing conversation in the research community about whether that is. In the things that we use on our bodies and to clean our houses are designed to evaporate, and they evaporate relatively quickly. And so they're unlikely to change the amount that gets into the atmosphere on a hot day and a cold day. But those solvents in paints and other kinds of things that might change that are where they're outdoor use. Okay, so let me turn now to ozone chemistry and sort of overlay what you heard from Sarah and what I've told you so far. One of the key things I told you so far is that there's more VOC in the atmosphere on a hot day than a cold day. And so Sarah showed you one curve for ozone versus nitrogen oxides, and here I show you three, just to make the point that you move along a different curve when it's hot than when it's cold. And so that transition point between VOC control and NOx control changes. It's different on a hot day than a cold day. And it's at higher nitrogen oxides on a hot day. And then just to highlight in all of the slides, I'll show you the filled circles are what we think goes on a weekday, and the open circles on a weekend. So we stay at about the same organic chemicals in the atmosphere weekdays and weekends, but we move the nitrogen oxides. So a weekend is an experiment of what happens at the same organic chemical mixture in the atmosphere. Yeah. So, and again, moving along those VOC curves is hotter, and what you're looking at is how fast you make ozone. So that's what that curve is. So ozone is made faster on a hot day than a cold day. Okay, so we assembled the observations of ozone, and in the way I mentioned to you at the beginning of this presentation, in a framework of thinking about what's the odds of violating a standard at some ozone threshold on a weekday and a weekend. And in this case, we did it for the San Bernardino site, but we've done this for many locations. This is just an example to give you a sense. The top figure is a hot day. The bottom figure is a cooler day. And then we can follow along in time. The blue curve is 25 years ago. So 25 years ago in San Bernardino on a hot day, you were more than 100 ppb ozone almost every single time. A little bit more often on the weekend, but it was 90% on a weekday and 100% on a weekend. Today, we're down about 50% of the time. And if that red curve is hinting that we're now in San Bernardino, less likely on a weekend to violate the this threshold ozone standard than a weekday. So that's where we would want to be. We would like the weekends to be lower than the weekdays, presented in this way, the odds of violating the standard, because that's a prediction for what will happen on weekdays when we have NOx controls of 50% going forward. But you can see on a cold day, we've eliminated, there are none. We're down to zero. None of the days on a cooler day are we violating the ozone standard in San Bernardino. So this is, with a threshold of 100, we've made incredible progress. Entirely eliminated high ozone at low temperatures.
I have a quick question.
Please.
Your previous slide mentioned the other sources of VOC are more important than cars. And you mentioned among those are trees. And so I just was curious if there's any data that highlights kind of a spectrum of which trees are, on the higher pollutant spectrum. Well,
So
I did hear that, but
yeah, so no, there is data. Our ecology and biology friends have measured the emission rate of isoprene and other chemicals from a wide variety of trees. I just don't know it well enough for the particular ecosystems in this basin.
thank you. I thought we had mentioned that in the past. Do we have a existing list? Okay,
We do have an existing list, and we'll be able to provide that to you, Mayor.
okay, thank you.
Sure.
I just want to point out that we do have a control measure regarding trees, so that's, we do have a biogenic control measure where we're looking at education and outreach to make sure that folks select lower VOC tree species.
I'm just going to say we had a briefing with one of our arborists or tree service providers for Yorba Linda. We have about 28,000 trees. It was interesting to me that we had that many in Yorba Linda. And there are, at any given time, 100+ dead trees that are being removed. And I can imagine that across 34 cities in Orange County and 24 cities in San Bernardino County, so on. So as to our ability to get that information to cities as they are removing and replanting, that was really my point as to we could probably make some great inroads just from that standpoint alone. So I'll look forward to being able to share that with it. For example, when I'm meeting with the Orange County Council of Governments, to be able to disseminate that. So appreciate that. Thanks.
Ben?
Go ahead, Michael. Yep.
Carlos, thanks. We just doing our budget too, and I remember putting a little part in there for West Coast arborists, which do most of the San Gabriel Valley. We put a budget aside for that. But we just celebrated in most cities, I think, in the region, Arbor Day, and we're a Tree City USA, so it's important for our community that we plant a lot of trees. So this is a very important thing. So thanks for bringing it up.
And we should remember that trees serve all kinds of other important purposes. Trees are an important way of cooling communities. So that weighing the complicated costs and benefits of trees and the different sectors and the different kinds of services they provide will be important to any overall evaluation.
Yeah, Dr. Cohen, first I want to say go Bears. But going back to slide 15, maybe I don't, I'm not having a little trouble understanding it. I thought you said that there were less heavy-duty trucks on the roads in the weekends. Therefore, there's less NOx on the roads in the weekends. Therefore, we would expect less ozone on the weekends. But if you go back to slide 15, I'm just a little confused then, just the next slide.
Yeah.
I'm confused. Wouldn't we, reading this slide, it seems to be that the odds of ozone being higher are higher on the open circle, which is the weekends,
Yep.
and less on the weekdays. I don't understand that.
So let's look again at this curve on this slide, slide 14. If we're in a place in the chemistry where that orange pair of dots, circles, is relevant, then you would have more ozone on the weekend, because we're moving to lower nitrogen oxides, and on that side, ozone is made faster. And if we are able to move a location or the basin as a whole across that peak to the other side, then there you see the green open circle is a weekday and is a weekend, and the green solid circle is a weekday, and then you would have less. So we're looking at two metrics here. We're looking at the decrease in nitrogen oxides and whether if the odds of having high ozone or a high ozone event are more on a weekend, it tells us which side of this curve we're on, and that what we need to do to get to the other side, how much further the nitrogen oxides are.
So this table, we're actually reading this table from right to left as opposed to left to right, like we would read a normal table, sort of? Like we're on the right side of this table right now, and we're trying to get to the left side of the table. Is that right?
So,
to get over that hump going.
So we are trying to get from the high nitrogen oxides, which are in the orange side of that,
Right.
to low nitrogen oxides, which are in the green side of that. That's the direction of movement in reducing nitrogen oxides.
So right now, we are in a situation where we're seeing higher ozone on the weekends.
Right now, I'd say overall in the basin, you're sitting right at the peak, so that you have some locations that are in the green and some locations that are in the orange situation. So,
And your conclusion is that that's because of VOC's reaction with heat?
my conclusion is, so let's take that in two steps. You see here that in every year, the odds of violating the ozone standard on a hot day are more than the odds of violating the ozone standard on a cool day. The nitrogen oxides are the same on hot and cold days. So the only thing that's changing hot to cold is the amount of VOC in the atmosphere. And the heat, yes. But the primary effect on the ozone chemistry is not the heat. The primary effect is that there's more organic chemicals in the atmosphere on a hot day. And so that's what you're seeing here. And you're seeing that on a cool day, the combination of NOx and VOC controls over the last 25 years was unbelievably effective. That you went from a situation that was 60% of the days, weekend or weekday, were in violation of 100 ppb 25 years ago. Today it's 0. This is an incredible success. It's 0 on a cool day. So but still, half the days on a hot day are in violation of the standard. And there's just and for most of the first 20 years here, weekends were higher than weekdays, as you point out correctly. But in the last 5-year period, it looks like, and the weekends are now lower, the red curve, which is the last 5 years. So that's a hint at least, and you can sort of maybe see a hint that those lines are changing slope over time. And so that's a hint that the chemistry was changing in the ways we were intending overall. Now, that's 100 ppb, and that's not today's standard, right? So we need to take a look at what we would say relative to the 70 ppb standard, and we're not there, right? The 70 ppb standard, in this way of presenting, you get no information because every single day on a hot day is in violation of the standard in San Bernardino. But we see a hint here that on the cooler day, that, the same sort of a hint that those lines are tilted up, that for the first 20 years of this record, weekends were more likely to violate the standard, going from about 75%, say, in the green or the blue lines to 85% on the weekend. So a slight increase in the odds. But today, that's about flat. And so today, we're likely sitting, as the other curves showed us, sort of near the peak, hovering there, and additional nitrogen oxides are likely to push us over the edge to we're in a good place. So that's what I would want you to take away from this, that we're sitting collectively in the basin right about the peak, some sites on one side, some sites at the other, but further nitrogen oxides will push everywhere over into that other side where the nitrogen oxides are giving us an ozone benefit 1-for-1, even if we do no further VOC control. So, as I mentioned earlier, our work looking at CO2 emissions in the Bay Area. During the shelter in place here, we did also sort of an experiment, right? The kind of mass change in emissions and behavior that you can't otherwise do. So we took a tremendous number of cars off the road. It was about half. That ended up being something like the weekend NOx control. We reduced NOx by roughly a half because we took half the cars off the road. So we moved on that curve. But it turns out, and there was sort of an expectation that we all are drawn to this idea. If we reduce emissions, we'll immediately see a benefit. Turns out that April was unusually warm, and the effects of temperature outweighed the effects of NOx reduction. So we had a lousy ozone season during the shelter in place because it was hot, because there were more the added VOC to the atmosphere because it was hot outweighed the reduced nitrogen oxides by quite a bit. And that's a tough sell, and it's hard, but at least I hope that maybe framing it this way as the odds of being in violation of the standard on a hot day or a cool day help you to think about that and help you to communicate that to other audiences. So that's really what we're looking for here. We're looking for ways to communicate the challenge before us to get to the clean air that we would all like to get to. And specifically, the ozone was high on weekdays in those events, and it was similar to what happened on weekends in other years. So roughly the same NOx control and the same VOC. So, as I wrap up and open for more discussion with you, I want to remind you of this observation that we have twice as much VOC in the atmosphere on a hot day than a cool day, and that much of that is from things that are not normally regulated, trees and other things that we don't control, and other also things that are more on the evaporative side of emissions than the direct engine use side of emissions. So here's the kinds of things I think you should be thinking about as a board. I should say I'm a chemist, not a policy person, so take this with appropriate grains of salt. But I think aggressive transition to zero emission technologies is an important way forward. That will help on our greenhouse gas and climate front. It will support a future where the number of hot days in Los Angeles is not increasing as fast as otherwise. We need to collaborate with the rest of the planet to achieve that. But we can do our part here to reduce greenhouse gas emissions. When we have zero emission vehicles, they're not emitting CO2, and they're also not emitting NOx or VOC. So that's one of our most complete control measures. So everything we can do to support that is a good thing, both from an air quality and a climate point of view. Trucks will also be part of that. That's a harder story in a different market, but it's possible. There are, continued control of anthropogenic emissions of organic chemicals is important, but we should recognize there's diminishing returns. Because the natural sources are such a big fraction, especially when it's hot, extra spending and effort on that area is not as beneficial as other opportunities, and is not as beneficial as it was 10 years ago. I would say a NOx-focused strategy is probably the only way to get to the goal. So we can, VOC reductions are maybe along the path, but to actually get below 70 ppb on a consistent basis on both hot and cool days, NOx controls are probably the only way. And then we should, as we've discussed a bunch of times with you already, we really need to be attentive to what trees are planted. That will be an important piece of the story, and that trees will have the benefit of reducing temperature in some places, and so that's an indirect benefit. So if it reduces the number of hot days or how hot it is, that's not an insignificant contribution to reducing ozone just in a really different way than we normally think about trees. Thank you very much for listening and your questions, and I'm happy to continue this conversation with you.
Thank you for a great presentation. And if we could maybe just drill down a little bit further on why the ozone was higher in the past on the weekends. I think we're still a little bit of confusion on that bell curve. I think we get parts of it, but then I want to make you ask that one more time. But was there other things going on the weekends? I mean, I know my grandpa used to burn all his trash on the weekends up in Pasadena, right? So is it the old charbroil barbecues? What else could there be that would really correlate to that?
There's really nothing else. It's really just that curve. Just that when you're at high nitrogen oxides, when you reduce them, you make ozone faster. And that's the South Coast Air District has led the way in a strategy of simultaneous NOx and VOC reduction that's moved us from curve to curve, from a high VOC curve to a low VOC curve. But all along the way, you're in that situation where when you reduce the nitrogen oxides, the weekends are worse than the weekdays, because until we get over that hump to the low side.
So it's because there's just less trucks on the road, but that puts us in the wrong part of the curve, which, okay.
Yeah.
Until we get over the hump.
Yeah, and that is,
Can I ask if, is that the same thing, the same point you were making earlier?
Yeah, sorry, operator error on the mic. Yes, that was the same point I was making earlier.
I'm still not understanding here. So individuals can't do something in their households to improve the situation at all? I mean, are there things that we're doing that we shouldn't be doing, or just everyday life?
so I would say mostly no. You know, it could be that what should I say? I think the most important thing we can do collectively is to reduce NOx emissions, and that's mostly running engines. It's engines in our cars, engines in heavy duty trucks, and engines in industry. So that's the number one thing. So you could imagine correlating hot days with asking people to drive less, but you can also imagine how effective that'll be. So, you know, if we're, you know, the real way that individuals can make a difference is by using newer vehicles that have better catalysts. That's how we've reduced NOx to this point, and moving to zero emission vehicles. That's the most important things that we can do as individuals, you know, collectively. But there's not small changes in behavior on the weekend are not going to make a difference.
So Stagecoach and Coachella Fest are okay then, I guess. They're both in my backyard.
Yeah.
I just wanted to add that, you know, we've been talking about ozone today, but as Ian reminded me, we also focus on PM and toxics as well. And so there could be some other steps that individuals could take that would reduce toxics, you know, using like less toxic consumer products, for example, or, you know, addressing those. And we have education and outreach materials on that. So, you know, there are some other steps that people could take, probably not on ozone because of the dominance of NOx, but if you wanted to be, you know, more concerned about PM, like wood burning strategies, for example, could really help improve those situations.
Mr. Chair, if I could just ask, because I sense there's still some uncertainty. And it really is the curve and the availability, right? And I just want to make sure that we all understand that. And maybe if we could just sort of go through again with the decreasing NOx, how there's a slight uptick. And we see that. That's what the curve shows us until we get to that critical point where there isn't enough NOx. And then that's what really drives it down.
Right. We were just discussing it gets worse before it gets better.
That's right. That's and that's what the
Right.
curve shows.
Right.
Right? Does that help?
So that explains why on a weekend, when there's less NOx in the air, the ozone is higher.
Can we show the curve?
Should we put up yours or mine, Sarah?
Yeah.
Yeah, Paul, if you could scroll back through Dr. Cohen's presentation, we'll tell you where to stop.
There.
There.
Right there.
Do we have a pointer so we can actually sort of show?
You persuaded Larry, so it must be right.
So,
Yeah.
so let me just try one more time.
Yeah.
Anyway, but I'm glad Larry's persuaded.
Me too.
So if you look at these three curves, think of those three curves as different amounts of emissions of organic chemicals to the atmosphere. And 20 years ago, you were able to move from one of those curves to the other by reducing organics in the atmosphere, by changing the emissions from cars and trucks and other sources. And today you're less and less able to move down from the top curve to the bottom curve through that method, because the background and the other kinds of chemicals in the atmosphere that we can't control through policy are a bigger and bigger fraction of what sets which of those three curves you're on. So that's one part of the story, and that's why the VOC controls have been so effective, is that you were able to move from one curve to the other in the past. But now we move from one curve to the other mostly by changing the temperature, which we can't change. So on a hot day, we move from that bottom curve and the rate of the ozone production that you make on that bottom curve. On a hot day, we're on the top curve. And then over time or on a weekend, we can change the amount of nitrogen oxides through a different set of policies and controls. And you see here, if we're in a place in the amount of nitrogen oxides in the atmosphere where we're on the, looking at the screen, our right, where we move along that orange pair of circles. We move from making a little bit less ozone on a weekday to making a little bit more ozone on the weekend. But when we move, and the arrow is there now, even at NOx, the way we move from the solid circle to the open circle is to decrease NOx. Absolutely. So the technical answer, I'll do that, and then I'll see if I can find a more qualitative way. At really high NOx, the nitrogen oxides do a set of reactions that shut down the chemistry. So if we imagine you make, in a relative sense, for every nitrogen oxide you put into the atmosphere, at the peak of this curve, you get 10 ozone. As you get to higher and higher nitrogen oxides, for every nitrogen oxide you put in the atmosphere, you only get 3 or 4. And that's because of a set of, a place in the chemistry that's a branch point where you can go down path A or path B. So I don't know if that's helpful, but.
Does anybody?
And our decades of data bear this out.
Absolutely. Everything we know is self-consistent with this. Our data, full computational models, all the different ways we approach this problem are consistent in that way. And that's because of this. This is exactly why you've pursued policies of VOC control for so long. Sure. So at that filled circle you're at, let's imagine those NOx concentrations are about 20 parts per billion, just for the sake of argument. This is just, right. So this is a high NOx concentration on a weekday. In the basin right now, that might be something like 15 parts per billion. This is a lower concentration on the weekend, about half that, about 7. And we would get noticeably more ozone, or in the way I showed you, the odds of violating a particular threshold would be higher, because this side is how fast you make ozone. So as we reduce NOx from this going in this direction, we make ozone faster and faster up to a point where we get slower and slower. But if we want to make ozone at this speed, there is no, you see that all of these curves on this side, they don't care very much by comparison how much organic chemicals are in the atmosphere. They're close to each other in parallel. So if we want to get to low ozone production rates, the only way is to get to low NOx. Because out here we're always faster.
And what data do we have that shows us that super duper steep slope once you get past the top of the curve? Is it the data that's showing that the effect is evening out now, or it's data from other states, or how do we know that?
So we could assemble a curve like this from all the cities in the United States as an example. And if you assembled all the cities in the United States and places where there's lower population density, almost all of them are on that side of the curve already.
And is there, have people done that already, and can we?
Yeah, we've done that in recent papers, and other people have done that. So yeah, yes. Yeah. So.
Well, next time Mary McCallan's going to give the presentation.
So does that help, understanding the NOx limitations and where it is on the curve? Thanks.
Thank you. Great presentation.
My pleasure.
And we'll go ahead and take some public comment at this time. First up, Yassi. Followed up by David Rothbart. And if anyone's online and wishes to make comment, they would need to raise their hand at this point. And if anyone's still in the room that wants to make comment, please fill out a blue speaker slip and give it to our clerk. Go ahead.
Hi, good morning, everybody. Thank you so much, Dr. Cohen, for an enlightening presentation. And I see that curve as a growing pains scenario where, you're trying to do the right thing, but you can't help but struggle through it. So I'm here for that. And I want to emphasize a point that Dr. Cohen made about zero emissions. My name is Yassi Kavazada. I'm a senior campaign representative with Sierra Club National. I'm working across the country actually on the growing concerns of the e-commerce boom. So I'm super excited to be here, but I started my career doing this work right here in the South Coast. So according to a new report about the zeroing in on healthy air by the American Lung Association, finds that switching to electric trucks, buses, cars could save 110,000 lives and bring 1.2 trillion in public health benefits across the country just by switching to zero emissions. And this is data collected nationally, and 1.7 trillion in climate benefits over the next 30 years. The report also offers localized data for California. For each state, we see a potential for $169 billion in cumulative health benefits, over 15,000 lives saved, and over 440,000 asthma attacks avoided between now and 2050. 2050 seems like a long time for me, and I'm hoping through the AQMP control measures and the indirect sources rules that you all are working on, we can continue to identify and make zero emissions a priority. I know there's a lot of tension about the cost. I saw the projected, I wasn't here yesterday, but I read through the slides about the socioeconomic analysis, and I'm hoping we can get a head start in that analysis and calculate the public health benefits and the cost for that. That was done later on in the warehouse indirect sources rule process, which we really appreciated, but we're hoping actually by mid-June, we can also incorporate public health benefit costs savings as well. So that's basically my comment to include that. And we can do more anthropogenically on VOCs. I know we can. I know we don't have straightforward policies to do that, but I'm really excited to get over that curve together and see what we can do. And thank you so much.
Thank you, Yassi. Some great comments. And by the way, everybody, it was Yassi's birthday yesterday, so happy birthday. Go ahead, David.
Thank you. Good morning, Chair and board members. I'm David Rothbart. I'm representing the Southern California Alliance of Publicly Owned Treatment Works. We essentially operate wastewater treatment plants primarily. We're essential public service. You want to flush your toilet, we need wastewater treatment plants. And I sit here as an essential public service, and I appreciate the chemistry. I'm a chemical engineer. I appreciate the hydrogen, moving to electricity. It's all needed. But one thing we're not talking about is how to get to attainment. It's very clear. It's very difficult. And it's extraordinarily difficult when the source is something beyond South Coast control. Essentially, 80% of the emissions that have to be reduced come from mobile sources and federal sources. And our partners have not been able to reduce those emissions. This feels like Groundhog Day to me. Back in the 2016 AQMP, we're having the same discussions, and we needed CARB and EPA to step up and reduce emissions. In fact, in the SIP, that CARB was supposed to reduce emissions by over 100 tons per day of NOx. That hasn't happened. I brought that up recently with CARB's activities to electrify, and said, hey, it's great to electrify, but that's going to take decades. Hydrogen, it's going to take decades. And the problem is the philosophy of when to do this and what the consequences are. It makes sense to get the air as clean as possible now, but what's the consequence of saying we're picking electrification or hydrogen as what to do? The only tool in our toolbox, what's the consequence? It's going to take longer to get to attainment. When we fail attainment, there's the 2016 AQMP, we're going to fail that in 2023. CARB has said pretty much we're going to fail it. It's no big deal. Well, I respectfully disagree. There's this thing called the Clean Air Act, and it has penalties upon stationary sources, withholding federal highway funding, and offsets that would have to increase. The result could be a permanent moratorium. So as an essential public service, if I want to put in some processes that could reduce emissions, I may not be able to do it because I may not get a permit. So I really want you to think about how we can go forward, comply with Clean Air Act, deal with the penalties, which honestly, the Clean Air Act isn't set up properly. Maybe we need to work with EPA on making sure we have the right motivation for the stationary sources and mobile sources, get everyone working together to have some reasonable solution to get to clean air as quickly as possible. I'll leave you with that. Thank you very much.
Thank you, David. Any other public comments? Not seeing any. Get a comment? No. All right. Any other closing comments or anyone else on staff or? No? Okay. Thank you. Again, great presentation, and I think it helped a lot of us get a better understanding of what we're up against and the growing pains we're going through.
So again, it was really my pleasure, and I'm more than happy if you would like to chat more individually to reach out to me, and I'll try again.
Doctor. All right, our next presentation will be for incentives and rebates for zero emissions. Dr. Aaron Katzenstein, go ahead.
Hi, good morning, Chair Benoit, members of the board. Jack Brower, we're out our clicker. So yesterday, Dr. Reese presented on the stationary area source emission reduction and control measures. And this presentation is going to focus on just solely on the residential combustion sources and what we're looking at moving forward. So in the proposed AQMP, we have our 2018 baseline around 12 tons per day from the residential sector for NOx. Moving to 2037, it's estimated that we're looking at 10 tons per day for the residential sector. So only 2 tons per day NOx reduction. In the proposed AQMP, the idea is to bring this down to close to 4 tons per day of NOx through control measures, which we'll get into here shortly. So this is the list of the stationary source control measures, and on the left, the residential combustion sources are covered. So we have water heaters, space heaters, cooking, and others like pool heaters that can contribute NOx in this sector. So looking at what's being done so far, on the very top, we have the California Energy Commission. So right now they're finalizing the 2022 Title 24 energy building standards. So these should be finalized here hopefully in the next couple of months. Something new that's been added to this, they are moving towards more zero emission appliances and building for new construction. So what they're looking at right now is that if you build a new home, you have to either install a heat pump unit for heating your air spaces, your interior spaces, or install a heat pump water heater or a thermal water heater as part of the new construction. The California Resources Board is looking at point of sale for appliance replacements as part of their SIP strategy. Bay Area AQMD is implementing rulemaking right now for point of sale appliance replacements. And then the city of Berkeley, Dr. Cohen's hometown, was the first in the nation to really implement zero emission for all new building construction. And they are working on a phased-in approach that's going to have point of sale for new appliances for zero emission. And by 2045, they hope to have all their buildings and homes in the city all zero emission. So our approach here is looking at the combustion sources, the appliances. There will be a regulatory aspect moving forward, so perhaps we look at point of sale as part of this. And there's not some of the emission sources you cannot replace currently with zero emission technology. So in those instances where it's either not cost effective or there's not a technology available, we have to look at lower NOx technologies as a replacement option. And then part of the strategy moving forward also would be incentives. So incentives are going to play a key role here in this implementation. So looking at our building stock here in Southern California, we have 6 million homes. And what you'll see is that most of these homes, residences were built prior to the Title 24 energy standards being adopted in 1979. So these standards back then were not very stringent. So there's a lot of opportunity here for one, weatherization efficiency. There's also a lot of homes that have older appliances that need to be replaced. So looking at some of these technologies, in the upper right, you see a traditional gas furnace. That yellow line going to the furnace is the gas line, and essentially it's combustion. And so as we brought up before, your efficiency for combustion cannot exceed 100%. You can't get more energy out of combustion than it provides in the molecule that's burned. Whereas with a heat pump system, you can get over 100% efficiency. You're not producing the heat through combustion, you're transferring the heat. So I put this diagram together to hopefully explain a heat pump. Hopefully it shows. So if you look at the left side, a heat pump is an air conditioner. And the way an air conditioner works, it takes the heat from the inside of the house and transfers it to the outside condenser. So on the bottom left is a picture of a condenser. And so if you run your air conditioner and you go outside and you put your hand over your condenser in the summer months, there's hot air coming off that condenser. So what a heat pump has the capability of doing is reversing this system. So you run it backwards. So now that condenser becomes cold and it's pulling heat from the outside environment and moving it into the interior space. It's a little counterintuitive because you think, it's really cold outside, how can I get the heat from the outdoor environment into my house? But these units are very efficient at grabbing the heat and moving it to the indoor space. So heat pump technologies can also be applied to water heaters. Once again, the efficiencies transfer over to the water heaters. So on the left side, we have a traditional gas water heater, and on the right side, we have a heat pump water heater. So in this case, the heat pump water heater naturally is going to heat up the water, which the other benefit is this will air condition your space. So if you have this in the garage, it helps cool your garage down. Oh, okay. So one of the questions that came up earlier is looking at the costs for installation cost scenarios. And this is hard data to find. So we looked at an E3 paper that has some estimates in here. So if you install space heating, a traditional Forster or central furnace with an air conditioner, depending on the size of the unit, the difficulty of installation, can run you between $12,000 to $24,000. And the prices they quoted for the heat pump systems are $9,000 to $17,000. Once again, each situation for each residence is going to vary based on what the current setup looks like. For natural gas tank water heaters, $2,000 to $2,600. And then when you go to the all-electric heat pump water heaters, the expenses go up quite a bit because the hardware costs are a lot more expensive. I just want to quickly compare, if you just look at the hardware cost directly. So here we have a 4-ton AC system with a natural gas furnace. So it's $3,800. And if you just were to purchase the 4-ton similar heat pump unit, same price. If you go up to a little bit higher efficiency, same thing. Prices are about the same for the hardware. Just directly comparison. So some other technologies the heat pump units can be applied to are pool heaters. Right now, it looks like heat pumps can go up to about 150,000 BTU. So if you have a large pool, like say the 450,000 BTU, you need to you want to install a heat pump unit, you'd probably have to install several heat pump units or go to a lower NOx combustion technology in those larger situations. But in our basin, we have around 200,000 of these pool heaters in place. And other technologies are residential cooking. So a lot of people like their gas stove tops. But they are a source of NOx, and also they have other indoor air quality concerns. The other side of things, when people think about going electric to the cooktops, they think about electric resistance. Those are very inefficient, and having used those in the past, they're very terrible. They're hard to work with. So this would not be a popular option if we were to say, okay, you want to go to electric resistance. But the other option is induction cooktops. So they're very efficient. They have very precise temperature control. They can heat water basically 50% faster than a gas cooktop. But the one downside is you have to have induction ready pots and pans. So it has to have iron basically in it for these systems to work.
Hey, can I make a quick comment on that? It's a big upgrade to go at for your countertop, but you can get on Amazon for about $80 and buy a portable one and plug it in and then try it out. And it does work really well. And in fact, I had a birthday party recently where a friend of mine came over and made tortillas by hand, and all we used was that, and it worked great. So it does work. And then if you're into cooking with cast iron pots and pans, you got what you need. So it's not exactly a huge issue. And then if you can later on, great, change out your whole stove. But the other thing is, for a lot of homes, obviously, if you have natural gas, you don't have a 220 outlet, so you're not going to be able to easily change it over. But at least to get started and just to try it out, Amazon, it's not a huge cost factor. And then your one primary burner in your house, or not burner, excuse me, a heating element for cooking is that, and it's very, not that hard.
What's the cost range for induction?
Oh, to do that, I mean, to buy a whole new stove, it's not cheap, not as cheap as buying just a gas appliance by far, right?
Yeah, there's a premium on those. So I installed one 2 years ago, and it costs around $2,000 for the stove and the cooktop, and I think they've gone up in price recently.
Yep.
And your comment on cutting the countertop, I had to do that, and my wife was very nervous when I did that. I didn't install myself.
Or adding a 220 outlet might be it.
Fortunately I had a 220 before, because I keep my house came with a stovetop, but.
Right. If you have that, you're in a good spot. If you don't have that outlet, then you're really going to climb up a steep hill, but just buy one burner.
Does that include installation costs from an electrician or something like that? Or?
No, that's just the unit.
Yeah. If you don't have a 220 outlet, you've got to get an electrician out. And in my case, I'm already solar, electric car, electric heat pump, everything else. I'm out of room on my 150 amp panel.
Then you've got to upgrade.
I can't do that.
You can't?
Not without upgrading my panel.
Oh, okay. How much is that going to cost?
That's about $3,000 just on its own, just for the panel. Okay. And then, by the way, only so many of us in my neighborhood can do that before Edison would say, your transformer's out of luck, and you, the last person in line, Mr. 6 out of 13 in your neighborhood that wants an extra new panel, you got to upgrade the transformer. So some hurdles there, but again, for that one opportunity to have at least one good induction burner in your house, it's not that hard.
Just for the heat pumps, that discussion, that didn't include installation and all of that.
Let me just go back here. So these are the costs of the hardware, and then the previous slide, this is installation with the hardware, estimated cost.
For some reason, the average AC guy thinks this stuff is still magic and wants to charge you more for it.
Yeah, that's true. They don't also have a lot of experience with these yet. So they also want to address solar. So you heard Dr. Brower talk a lot about solar yesterday. This is residential solar, not the grid scale solar that he was referring to. But essentially right now, if you install solar on your rooftop, and for example, if you're in Edison territory, so Edison has time of use rates in place. So your rate that you're charged for electricity varies on the time of day, and that's largely dependent on demand. So if you have solar installed and you're put on this time of use rate for the new installations, if you're using all your electricity from 8 a.m. to 4 p.m. and your solar is producing, you're in a pretty good spot. That's going to work out well for your household. But if you come home, if you're working during the day, you come home, your solar power starts to shut down, you're going to get charged 53 cents when you come back, because essentially what happened is your solar panels produced, the utility paid you a very small amount for that time it produced, and now it's charging you the full rate for when you come home. And so during these time periods, it's demand pricing, so that there's a lot of demand on the system. They don't want to add new generation, so they're trying to reduce the demand on the other side. And then going to the 9 p.m. to 8 a.m., we have lower electricity demand, but that's when most of the fossil plants are on right now. So now the big thing is, in these situations, if you add storage to the situation. So hypothetically, your solar panels could charge your battery storage system, or you could charge the battery storage system when the rates are cheaper at 33 cents. And then essentially what you do is you discharge it, and you're going to be paying 33 cents if you charged it, during off-peak times. Or if you paid for your whole system, technically you could go off grid, you charge your battery system and discharge it whenever you need it. So the other benefits of storage, Dr. Brower mentioned like the utility scale, the larger diesel backup generators, but this is also true for residences. If you have power outages, like say public safety power shutoffs, backup generators for homes are soaring right now. A lot of homes are installing these just to provide a safety measure for if the power goes out. So storage can provide this safety measure. It can power your house when the power goes out for limited duration. The other benefit of these storage systems is the utilities can use them for demand response. So there's programs where the utilities will shut off your air conditioner when there's too much power demand on the system. But this is a better option because it doesn't really, you don't have to shut your air conditioner off. It can discharge the battery during the times of need. And something that's very exciting, this is the F-150 Lightning. And they've set this up so that it's a bi-directional charger and it can help power your home. So the battery's in the truck act as the storage, and it can power your home during times of need. So it's a nice feature they have there. So looking at some of the other challenges here, around 50% of the residential buildings in our basin here are rental properties. So how do you, if you're a tenant paying utility rates, you're given the appliances you're given for the rental unit, how do you persuade the rental unit owners to upgrade to zero emission appliances? So this is going to be something we're going to have to tackle on how to do this. Another concern is electricity rates. Even though we're going to electricity, say for a heat pump, oftentimes, depending on the rate structure, when the appliances are used, the utility bills can go up a little bit based on these zero emission technologies. And then we're covering panel replacements. That's a concern if you have to go to 240. We'll get into that here more shortly. So looking at panel replacements, this panel on the left, this is my neighbor's panel. And he is completely, there's no space for anything else in this panel. So if you were to do a lot of these replacements, he needs to get a new panel installed. Whereas the panel on the right, there's lots of capacity. This is a new panel. And there's also, you don't always have to replace your whole panel. You could add a sub panel, but a lot of the ways the homes are built, you can't really add the sub panel very easily. It's just easier to replace the panel.
Sorry.
My panel looks like the one on the right, and my brother is a linesman, and he helped me replace it. So it was a lot less expensive than paying someone to do it.
What's the number?
How do you know there's extra spaces? Because there's those blank little.
Yeah, the one on the right, if you see all the breakers and you look up above it, those are the spaces that you can add more breakers, circuit breakers to.
I see, and this one has nothing available. Okay.
Yeah, the one on the left there's no space for anything. So looking forward, as we implement incentive programs and get this going to do these replacements, one way in the past we've done like weatherization programs for 1318, we partnered with the utilities. We used their incentive programs with our incentives and coupled them and provided a very beneficial incentive to the homeowners or to the rental, to the tenants in the rental units. The other approach also is to do a whole house approach. Well, instead of just replacing a stovetop, also look at the water heater, perhaps install an EV charger at that time, and just do multiple components at once. We'll get into education here in the next slide. And then we also want to have target implementation. So what's the low-hanging fruit here in this space? Likely the older homes are going to be, the bigger concern, not new construction. And then also helping out the lower income households with these changeovers. So part of this would be consumer education. There's a lot of unfamiliarity with the new technologies. So induction cooktops, it'd be good to try them out just with a little, like you mentioned, that's a good path forward to have the little plates and just try those out that way. And also have maybe demonstration centers where they can go to utilities and they have, all this set up and they can try it out, get familiar with it, make sure they're comfortable with these new technologies. And then once again, the rental units are going to be tough to tackle. We found that in the past, and we have to find a way forward with those. So just in our past, we've got the Clean Air Furnace Rebate Program. Initially, this was set up through 1111, and the $3 million helped convert 5,300 furnaces to ultra-low NOx. Those funds were pretty quickly, and then later on, it was adopted to basically incentivize the installation of heat pumps. And that incentive program went pretty quickly also. And I'll go through these very quickly. All the utilities have these incentive programs. Edison, we've worked with them in the past. SoCal Gas, IID is another good one, Coachella Valley, DWP. And then there's other programs in place like the Tech Clean California. Essentially, that's a statewide program funded through the PUC. And that's helping basically incentivize the purchase and installation of heat pumps and zero emission water heaters. And then different cities also have their own replacement programs. So just to conclude real quick, it's going to have challenges to do this. There's a lot of residences. It's going to be a little bit costly to do this, but we really need to get these emission reductions from stationary sources. And incentives, a little regulations are going to help. And then, as always, like our past incentive programs, the partnerships are going to be key. So with that, I'd be happy to answer any questions.
Got a few questions, but go ahead.
I just recently came across something that the California Department of Public Health is doing. It's for work, but they're essentially asking nonprofits to go into homes to remove lead paint from low-income units that were built before 1978. That each household is eligible for $16,000 of work, but we would perform it for them. Is that something that we've tried to partner with anybody? Because I just don't see how low-income households could navigate this whole system on their own.
Yeah, that's a good point. So in the past, with some of the programs, we have worked with some of the community groups to help do the outreach. And also with the utilities. Utilities have a much broader outreach to the customers because they send them a bill every month. So that's been very helpful to let them know about what the programs are available.
I just, as we move forward, I'd love to continue to model that and see if we could find funding from the legislature, not for us as AQMD to actually perform the work, but to partner with folks to actually start changing lives this way. So.
Thanks, Mr. Chair. Aaron, remember yesterday during Dr. Brower's presentation, he talked about when he was studying in his office the emissions of methane or natural gas. Maybe there's some way we can, how do you measure it? Like in a typical person's house, do we get an idea, they've got a gas stove, I've got a tankless water heater. What are the leaks in the natural gas? Is it a serious issue? And is there something we can do as we promote this, say, hey, here's the health impacts if you do natural gas leak in your home versus his office and all the other buildings on Irvine campus?
Yeah, well, his engineering building is pretty large.
Okay.
He's got quite a bit of pressure in this natural gas system also. But certainly, one idea, if we did electrify our whole house, you would turn your natural gas off.
Okay.
So that would be one option, is just to not even have that service anymore. But to measure, it's actually pretty difficult because you have to go to lower levels of detection. So it's basically like you got to go to a research lab to get this low-level methane detection to understand how many leaks are there in the house.
In current studies, is it an issue for human health in people's houses and the amount of leakage from this natural gas?
Well, methane, not to my knowledge, it's not really carcinogenic. It's in the air at ppm levels, 3 to 4 ppm. So it's you're breathing it right now.
Okay.
If it was
you're fine.
If it was a significant leak, then you'd smell the mercaptans, the odor in the system.
Thank you, Mr. Chair. For the older neighborhoods and lower income neighborhoods, it seems to me that the long pole in the tent is the electrical infrastructure that Edison has in place. And to really facilitate this, it seems to me that we would need to incentivize Edison to upgrade all of the electrical infrastructure before we could really implement this, because to put that burden on the lower income people in those houses, I think is not going to cause this to happen.
Yeah, so my understanding is everything behind the meter, well, you're responsible for your meter comes to your house and all the wiring from the meter to all your appliances, that's your responsibility. But everything else behind that is Edison's responsibility. So they should.
Not always.
Not always.
If you're in a neighborhood and let's say there's 10 homes in the neighborhood and 3 or 4 others have already upgraded their panel and they've done it with an electrician and actually applied to Edison and told Edison they're upgrading their panels, at some point, one of the neighbors is going to run into the transformer is impacted. Right. If you want to upgrade your panel, no problem. And Edison will tell you, here's the bill.
Right.
They charge the consumer for that. And it happens in industrial parks as well. It's a little misnomer that when Edison says, yeah, we can do that, no problem. The second sentence is, but you get to pay for it. So there is a cost there too. And Larry, you say older homes. I have a home that's 2004. I'm at 150 amp panel. You add solar, you add an electric car charger, you do a heat pump. I'm maxed out. I can't go to that nice new stove. even if I wanted to, unless I upgrade my panel to a 200 amp panel. So really where you have to get to is 200 amp panels. If you're talking about doing all these different things in your home, you need a 250 amp panel. Or some other way to magically switch the loads, and you can do some of that, but still that's very expensive, and now you have a very smart load center, or there's other devices where you can maybe split a load between a dryer, if it happens to be in your garage, between your dryer, electric dryer, and your electric car. But there's little tricks like that that can get you there, but boy, is it tough, and especially when we start talking about our low-income families and everybody else. But even moderately new homes are gonna run into this problem.
That's a good point. And I think that there's probably some differences between utilities, electric utilities, and what they're going to provide for those upgrades. Because I know up in Northern California where my brother works, he works for a public utility, and they will upgrade your transformer when you encounter that situation.
Maybe we need to talk to the PUC about that, and maybe that's a formula that the PUC needs to talk to Edison about, and maybe we all need to start paying a little bit more on our utility rates so that we can all let those neighborhoods upgrade when they need to upgrade. Any other questions? Who's gonna go home and put a new heat pump in? I already did mine. All right.
Portable induction.
Yeah, or the portable induction one, that's another easy one, and I find it was very impressive how well that worked, even for the one thing I was worried, which was tortillas. So you get a good cast iron pot, and you put that on there, and it's just like you're cooking on the gas stove, which is how my mom always heat up the tortillas, so.
I think I'm gonna try it out. Amazon, you say?
It's Amazon, I'll send you the link. Yeah, it's actually, I said 80, I just found one for 54 bucks, so they've come down in price.
Just,
Yep.
I'm sorry, one last
Yeah.
question that I just thought about. For our incentive programs, are they generally well used, or, I mean, are these depleted? Do you have waiting lists?
Yeah, so my understanding, TAO didn't administer the furnace program, but talking to Mike Kraus, it went very quick. In the past, the 1318 programs, we had a contractor out there that we approved, worked with the utilities to extend those funds, and we got 2,000, 3,000 homes weatherized in like a year and a half.
I think what this really highlights, Chair and Vice Chair and members of the board, is that we really need to work closely with the legislature to make sure that the funding is actually appropriated for these kind of things. Again, this gets to the state's responsibility and commitment to meet the clean air requirements. And if we have to electrify and go to no or to zero, then the state has to make sure that they're paying their fair share so that they meet their state obligations as well. So that needs to be the focus of a legislative campaign. And we'll try to also advocate that not only amongst the other districts, but CAPCOA and NACA and other groups like that.
Very good. All right, unless there's any other questions on that presentation, we'll go on to our next one, which will be our last one for today.
Chair, let's just call for public comment.
Thank you.
Don't think we got
Any
anybody.
public comment? I don't have any other public comment cards that have come up here, but do you have any online? And I do see a hand raised. Fernando Gaetan, go right ahead. Fernando, we'll get you unmuted here momentarily. There you go, Fernando. You should be able to unmute now.
Good morning, everyone. I'm Fernando Gaetan with Earth Justice. Thank you so much. Wish I could be there with you in person, but you're in good company with Yassi Kabazadeh. I want to thank staff, first of all. I know we talked about the AQMP yesterday, but I really want to express my thanks to staff for the approach they've taken to the working groups. It's been extremely helpful to have a line of communication to staff just to talk about the control measures and the plan as it was being developed, and I appreciate the approach they took there. Very quickly on the incentives, also pleased to see that the incentives programs will be focused on zero emission technology with the majority of the total funding. We would suggest that the total of the funding go towards low income and environmental justice communities to cover that whole home approach that you're talking about. With that, we do have a recommendation, and we put this in a letter back in December, to kind of work through some of the challenges of getting into those homes, those low-income rental homes, is to form an equity working group. This is something we've saw up in the Bay Area with some success, and it would really look at the long-term phase-in date for zero emissions NOx standards for space and water heating in existing homes, being paired with this working group, looking at the tackling some of the challenges that we see by engaging local community groups, affordable housing groups, environmental justice stakeholders in the development and implementation of plans and policies with an equity focus on doling out those incentive dollars. That's all I have for today. I look forward to commenting more on the ACAMP before the deadline, and thank you so much for your time.
Thank you, and there will be many opportunities to do that. Thank you for making those comments. All right, anyone else for public comment? All right, with that, we'll go ahead and, oh, sorry, Carlos, go ahead.
Mr. Chair, just one last question. I was wondering, Doctor, thank you again for your presentation. I'm curious if you looked at or had any opinion on the CPUC's current consideration on a proposed policy of a 80% cut on the solar credit.
Yeah, so that's net energy metering 3.0. Essentially, they're going to charge a monthly fee for interconnection to the grid, and I think that fee is proposed somewhere around $75. Also, the sellback credit from the solar to the utility is going to be lessened. So that's going to be, it's going to hamper the residential solar, but perhaps that's going to drive more storage in this situation if that gets enacted.
Any concerns about the unintentional consequence of hampering? Just as far as your perspective on your other comments, just trying to.
Yeah, yesterday that there's a lot of solar on the grid right now, and that a lot of it gets curtailed. So I think what we have to start looking at is when you install these solar systems with the residential households, you need to get storage. That's what it's really going to drive, is you need storage with that system.
Has there been a stance that your colleagues have on the current proposed decision?
I'm not aware that we've taken any position on that.
Okay, thank you. Yeah, right. It's currently tabled. That's what kind of the point of my question was, just kind of getting a sense of where you were on the upcoming discussion. So no stance.
Yeah, we haven't taken a position.
Okay, thank you.
Okay, any other questions? Before we move on to the next item, there's a hand raised on this item, so we'll go ahead and go back to public comment for a minute. The phone number ending in 373.
Hello, am I being heard?
You are, Harvey. Please go ahead.
Thank you. Hi there. My name's Harvey Etter. I'm speaking for myself and for the Public Solar Power Coalition, etc. Thank you, Dr. Katzenstein. I want to make sure everybody knows that you wrote the section in the 16 plan on solar and renewables and climate, and in responding to the draft of, I believe it was of June of 16, of the 16 plan, we wrote on the 12th of August in response to what you said. There was a 30% increase in methane over the last 10, 12 years. So we jumped on that, and on the new numbers that came out for methane by IPCC AR5, going from 2025 global warming potential up to 80, 85, 100 with radiative forcings plus. Okay, so we did this, we addressed that, we did the calculations, and we published them, and it's in the record. And it's about 7 years ago that the 450 CO2 and CO2 equivalent that the state had been using, EPA's been using, is wrong, that the numbers there, based on the 12 years in a 20-year cycle instead of a 100-year basis, et cetera, and the melting of the Arctic. And we gave that to you, got it to you and the Fabian 3 years ago in September of 19, the cover article from National Geographic. The Arctic is thawing, it's warming. That is not included at all in IPCC, okay? The number we came up with was 780 parts per million CO2 equivalent. A week or so after that, we made a presentation, you made a presentation to local government small business committee, and we confirmed those numbers. That tape of that has been manipulated and messed with. But this is extremely important. The real numbers are 2 to 3 times the 400, 450. That's right now, and we got to deal with the real. And we brought this up. There was a meeting between Germany and California in 17, and we got some interest from particular folks with the German utilities and whatnot. Anyway, that's in the real, and that's got to be dealt with. And these folks, like, you mean well that they named their name 350 and stuff like that. Well, look, folks, this is the real. This is what we got to deal with. And all this, Mr. Brower yesterday, I'm glad. We've been talking this stuff for 30 years with y'all and 50 years with the state. And we got to go with.
Thank you, Harvey. Thank you for your comments. Anyone else want to make a comment on this item? All right, we'll go ahead and go on to our last item. Dr. Sessa Johnson, go right ahead. Thank you.
Okay. Greetings, Chair and Vice Chair and other members of the Governing Board. Thank you so much for giving me an opportunity to provide an update on our diversity, equity, and inclusion goals as I presented to this board last year at your retreat. As many of the people in the administrative committee will be familiar, I like to take this as an opportunity to be an educational one. And so we have an opportunity to share information with you. Am I clicking the right thing? There we go. So today is Friday, so this is Fabulous Female Friday. And so I'd like to share with you all some information about Coretta Scott King. Her birthday was a few weeks ago, but there were a lot of learning opportunities for me. There was a wonderful video that we showed as a part of our monthly event, which is called Fabulous Female Fridays within the agency. Hulu did a Made by Her Monumental Women documentary, and I shared this with you all in your presentation. So if you have an opportunity to click on it, you can see it's an animated short, but it provided just so many informational things about Coretta Scott King that I hadn't been familiar with. In particular, her fight for environmental justice. She was not just concerned with civil rights, or she considered environmental rights to be part of our civil rights. She did not also believe in just racial African-American rights, especially toward the end of her life. She was an advocate for LGBT, for children, and the environment. And so I just found that interesting, and I wanted to share with you all, because part of systemic oppression in our society is the not so much diversification of our leadership. So I would like to share with you all information about Coretta Scott King on the anniversary of her birth. Next slide, just a presentation of what we will be sharing today. Just information about our DEI goals and accomplishments, examples of some of those things that we have done, initiatives within South Coast AQ&D, and then sharing with you what is going to be coming next. Okay, next. I'm so used to saying next slide, so this is awesome. So what I'm really pleased to share with you all is that in our goals for this past year of 2022, we had goals that we wanted to do 12 basically informational items to be able, 12 different informational items we wanted to share with staff. We wanted to support our employee resource groups, and we wanted to provide equity professional training. You can see that our annual goals that we expected to do, we have exceeded in each of those areas. And one of those, the ways in which we have exceeded, I'll be sharing with you on our next slides. The first thing that we do, really conscious of our staffs and the work that we do, we have a lot of crisis-related issues that come up for our teams. And so we want to be able to not always require people to attend a training. And so what we do is we provide informational graphics that are very interactive. We have utilized the pandemic and virtual learning to its advantage. And so we provide these DEI infographics during different cultural holidays or significant moments of remembrance to our employees. And it always offers a little bit more information where they can click on a further link. But these are just examples of what we've done in the past since July. So you can see a great deal and gotten a lot of positive feedback from our team. I didn't know, this is great. I'm so excited. Thank you very much. Keep doing that. Another example of what we do, we believe in also not just providing information to our staff, but to really enhance their critical thinking skills around DEI. So we have on the third Tuesday of every month is what we call our Jedi think tanks. And again, Jedi, no pun against Star Wars, but it's meant for justice, equity, diversity, and inclusion. And these are critical thinking opportunities for our staff members to come together across divisions. We average about 50 employees each time. They're about 1 hour long during lunch hour. And we just pick a subject matter, usually a video, and we just talk about it. We give them discussion prompts. We break them up into small groups, and they get to discuss things. They really enjoy it when Susan and Wayne are showing up, and then they get to sit in a breakout room with them. But it really is an opportunity for all of our team members to interact with one another. And so we've done 5 of them since October, and dealing with a variety of subject matters, the last of which was a very powerful video about the tragedy of air pollution, which was the story of a young girl who had actually died in London, and her official cause of death was air pollution. And just how does that impact the work that we do here at South Coast AQMD? So really powerful events that we do with our teams. The next thing that we do is we actually have virtual programs. We have yet to have in-person programs yet, but we look forward to those. We have done some displays in our lobby, and I think that some of our board members have been able to see those. We did a veterans flag display in November. We did a Persian New Year display just this past March. We've also moved toward having some cooking and baking demonstrations for Persian New Year. That was very, very popular. We also even had members of our governing board participate in presentations to our employees. So governing board member Rex Richardson actually presented in February, and then Supervisor Rahman has agreed to speak with us for API Heritage Month, and then Supervisor Kuehl will also be participating in June for Pride Month. So these are basically events that we hope host for the entirety of our employees, and just to learn a little bit more about different aspects of diversity, equity, and inclusion culture. We also have our 7 employee resource groups, and I've mentioned those to you before, but we have our Asian Pacific Islander Plus group, our Black Employee Resources of Change, Barack. We also have our lesbian, gay, bisexual, transgender, queer questioning, intersex, and asexual plus group, LGBTQIA, our Hispanic and Latinx for Success, HALOS group, allies and advocates, our Persian, and our veterans and active duty military families. And how we work with those groups is that I meet with those groups every other month with their leadership. And then the other way in which we work with them is that we have asked all of them to participate in different working groups. And so we have basically taken information from those employee resource groups that pre-existed me, that would be our API Plus group, Barack and HALOS, along with our IDEA panel. And these were all groups that existed before I was hired to be in my role. And they made recommendations. And so we've turned those recommendations into work groups. And these groups work together on these 7 different subject matters that you'll see here. So how can we improve in our community partnership outreach, educational equity outreach, employee professional development, employee promotion, employee recruitment, employee retention and engagement, and equity events, programming, and resources. And so with that, we have each representative of each ERG joins me in meeting. And so what we have, and since July, is all of those groups have come together, and we meet basically once every other month, and they give us recommendations. They give us what I call their lived, I'm sure many of you have heard of lived experience, but we're treating it as lived expertise. What is the experience that you've had within our agency? What is your experience working in our communities? One thing I feel that, when I first arrived here, there were some people who were a little hesitant, like, are you here to just take away my job? Are you here to just represent, we get a certain percentage of people to work here. And my job is not to do that. My job is to increase the cultural competency of every employee in our agency so that they can do their jobs for a diversifying community of people. That is my job. I am not here to take away anyone's jobs. I'm here to make everyone better. And so what I have loved is that all of these groups have come together to assist me in that, and they give me information. They give us their lived expertise about what is it important, what is it that active duty military families need from us as an agency. What do our veterans need to us from our agency? And how can we support them? And so we've come together, and they're not siloed. They meet separately, but then they also come together as a group to share with us. And so we've had 4 meetings of all of those different 7 work groups. We've had 90% ERG representation. That means that almost every ERG is always represented at these meetings. We have an all ERG meeting this past April, in which all of the representatives of the group came to hear all of the recommendations that have been made over the past 6 months. And so what I'm doing now is I'm doing a bit of an equity roadshow, and I'm going around to all of the different employee resource groups and saying, hey, okay, this is the information that we've gathered. This is the data. Is this in alignment with you would leave? Is there anything that we've missed? And then my next step is to go to executive leadership and to share with them all of these recommendations so that we can now develop a DEI strategic plan for our agency. So I feel that this is vetted by the employees. We're giving one last shot. I, of course, have been sharing with Wayne and Susan all along so that there will be nothing that comes up as a surprise. But we will expect to be sharing with you all whenever you expect to have the next update, share with you what those recommendations are. But we've been very pleased so far with what we've heard from our employees. So June 2022 is when we'll have our final recommendations that we will share with Executive Council leadership. And I believe that is my last slide. Any questions?
Very good. Questions, comments? Go ahead.
Yeah, so I want to thank you, Dr. Herb Johnson, for this presentation. And, on behalf of the admin committee and the rest of the board, looking forward to hearing back once you go through this deliberate and fruitful process administratively, and you come back to us with some things in writing about where you think the agency needs to go forward. So I know that we're all looking forward to that. It's something that can't be rushed. It has to be done the right way, and it seems that we're really committed to doing that. I'm just really thrilled. You've been here now 15 months, 2 years? How long has it been? 15 months. Yeah. So, really thrilled, to see the, the enthusiasm that you continue to show for the job. I think we can tell, that you are being supported in the work, and that you're feeling good about where you are in this time. So I think that really reflects very well on the executive committee. It reflects well on the executive management, that they're supporting you in this work, Mr. Nastri, Ms. Nakamura. This work is hard. This work is touchy. It's hard to actually see this work through, to actually make a difference. It's hard to see this work through and keep momentum. So, we're pretty well into this. I can see the presentation and all the things that you're doing, and, really encouraged that where we are, and hopeful that at the end of this process, with the board supporting you, with the executive committee supporting you, with everyone in the agency, supporting this work with your leadership, that we're going to see something come from this that really is informed by all the best practices in the field, that is a plan that makes sense, and is a plan that we can carry out, and measure. And everybody can look at this agency and say the AQMD, did it right, even though it's very hard to do. So I know we're still in the process of it, but I'm very encouraged and appreciate the presentation today.
Thank you. Thank you so much for your support. Thank you.
Very good. Any other comments or questions? All right, we'll go ahead and go to public comment. Harvey Etter, you have a comment on this item? Harvey, you should be able to unmute now.
Okay. Hello, am I being heard?
You are.
Thank you. Good morning. My name is Harvey Etter. I'm talking for myself and for the Public Solar Power Coalition, etc. Thank you for your presentation. We've been working in this area for about 50 years. And on the issue, we did a study for the PUC in '81 on the solar financing program, the Low Income Solar Equity Program. And as far as I know, it's never been reviewed by this agency, CARB or EPA, and it's in the record. And it advocated looking at equity. It was the first time that we had a 10% earmark for low income, because I was done with Dr. Grimes, the first Black commissioner of the PUC, et cetera. And so they had these various programs coming out. They just formed the Department of Energy and whatnot. So we wanted to coordinate these programs and leverage them and multiply that. But we were talking in equity, not just that areas with poor people, working people, whatnot, get the same, not more air pollution, the same as wealthier areas, just exposure to emissions and the external costs and whatnot. That also equity looks at who owns and controls this. And that's what we've been about. And that's what we're still about. And that the presentation we heard from Mr. Brow yesterday mentioned nothing about this. And it's extremely important. We helped start the CCA, which is the third largest electric utility in the state, the Clean Power Alliance of Southern California. We got Director Interlux with Sheila Kuehl, second vice president there and on the board here, et cetera. Okay. Fine, but this is not, we brought this up in 617 meetings, worker co-ops, et cetera. All this stuff is exploding right now, okay? It turns out that 60% of the solar renewables that went in, and that's like 80, 90% of went in worldwide, is controlled, owned by oil companies. Then from the South, we hear, oh, we want 40%. Well, it seems like a deal's been done. 40% of what? How's that controlled? Who's going to do what in the South? And to let the slave holders continue to control us as mechanical, industrial, information slaves, all right? Enough. We've got to get into the issue of equity now, and every program, there's hundreds of millions of dollars, those stuff does not go through. Nothing goes through unless it addresses the equity question, and these are through director interlocks of small business, vertical and horizontally integrated businesses in solar renewable sustainability. Okay, it's extremely important.
Thank you, Harvey. Councilmember Rahman had one more comment in 1 minute.
Yes, I just wanted to bring up one point, which is I wanted to congratulate you for all the work that you've put together. And I think particularly during the time when everyone is working remotely, building community is very hard work. And I think that the fact that you've been able to do that is really remarkable. And I hope that can continue and in person as we move into a different mode of life. We're in the middle of a still continuing pandemic. Mm-hmm. I did want to just mention that there are tech-based tools for reporting around harassment or abusive behavior that can be really helpful, particularly in large organizations, in allowing places for people to provide and receive feedback around issues related to workplace safety, yes, and workplace harassment. One that I'm familiar with is called Techquitable, and can provide additional resources for people who might be facing workplace issues. In general, the gold standard around creating systems that can really address abuse, racial discrimination, and sexual harassment in workplaces to have some kind of a third-party system, and a tech-based system can be really effective in large organizations. So I just wanted to provide that as a potential resource. There's a number of other tools, but Techquitable is a good one.
Thank you very much for that recommendation, and I'll also work with our Human Resources Department, but thank you very much.
Thank you, great comment. What was the name of that software again? Techquitable? Okay, I'll look for it. Thank you. All right, any other comments? All right, that brings us to the end of today's agenda. Any other closing comments from any of my colleagues? Did we all learn something, I hope? Yeah. Larry helped you out on that last part, so we're good.
Larry always helps me out. I think he's sick of sitting next to me between this and the board meetings. But Chair, how'd you think it went? Did you have any thoughts and appreciation for the staff? Or?
Absolutely. I just want to give all my colleagues a chance first, but no, staff, thank you. You've got some great speakers for us, and I think every time we do this, I know I learn a little bit, and after being on this board for 10 years, there's always an opportunity to continue to learn, and that's something I think we all have to work towards and continue. And I also encourage my colleagues when they get on this board to make sure that, try and stay as long as you can. It's it's tough when we see turnover because there's such a steep learning curve here, and it's always a little hard, I think, on staff when people rotate. But overall, I just want to say thank you to staff. Great for putting this together. It's well worth our time and energy and effort. This is definitely stuff we can't do at our regular board meetings. It's just too involved and takes too much time, and I think this is well worth the effort. So thank you. Larry, you have a comment?
No, Mr. Chair, I did note that the charts talked about San Bernardino, and that was helpful. Thank you.
Every once in a while, I'll put a little Wildemar on there too, man. All right, well, thank you, everybody. Everyone have a safe travels home, and hope everyone's feeling better soon.
Hey, you see, I have to